Hello everyone, welcome to the next topic on in the unit number 4 of energy and our environmental studies. In the previous video, we have seen the conventional energy or the non-renewable energy, different types of it. In this video lecture, we will be looking into the non-conventional energy. We also call it as a renewable energy like solar energy, wind energy, hydropower, biomass or bioenergy, hydrogen, fuel cells. So our objective here is to understand various renewable energy sources and their usage, highlight the merits and demerits of using these non-renewable, all these renewable energy sources, also to learn the energy conservation, how we can conserve the energy. Let's look into the total world energy consumption by source. So the renewable energy is 19% among the global energy consumption, so this is very small. This needs to increase over the time because we have seen the demerits of non-renewable energy, mainly the environmental concern. So this renewable energy are healthier for the environment as well as they are available in plenty. The only problem we have is the technology. But by the usage of these technologies over the time, we are expected to increase this percentage. There are this 19% covers all these different forms of the available energy, that is renewable energies like bioheat, ethanol, bioethanol, biodiesel, the bioenergy, hydropower, wind, solar, and many more, geothermal, like that. So let's look into these topics one by one. First, let me take up the topic on solar energy. The solar energy that is received by the earth is somewhere about 174 petawatts. That's huge amount of energy that is incoming. Of this, around 70% it is infiltrated into the earth and remaining 30% is reflected backward. So the energy that is available to use over the globe is two times the energy that you can obtain from the coal resource, oil resource, gas and uranium. You club them per year, two times of that you can get it, solar, and that's the quantum of energy that is available for use. And that does not stop there, it is never exhausting as far as sun is concerned. So still till the sun is there, you keep getting this energy. So the solar power beats all the other conventional sources of energy in terms of its renewability as well as its sustainability. That's what I mentioned. It's available throughout till the sun is there. Once the initial cost, yes, that is true. You have some initial cost that's required here. Once you have met that, over the time, the electricity that you generate by using the solar panel, you are meeting that, and after that, the energy that you get is free of cost. So that's how it is sustainable. So another good thing here is solar power is that cost of the technology is decreasing almost every few months and efficiency is improving significantly. That is happening over the years. If you look into the data of some 10 years back, you didn't have subsidy or so. You had a lot. The panel cost was very much, and the amount of energy generated was less because of the efficiency. Now the entire thing is turned over the years because of its increase in its usage as well as decrease in its what you call the cost of the panels, the new technologies that have been developed to increase the efficiency. Let's look into how it works. You have the solar energy coming into picture here. Solar energy, when we say, we have to think in terms of photons, right? So the photons are falling onto a frame. You have a framework like this here. You have the shields that are covering from the water or that's rain, air or any corroding material. It protects the solar panel. This solar panel in the middle is made up of silicon layers. So we have the N type and P type silicon here sandwiched, and there is a junction. So at this junction, what's happening? The photon flows over here, and there are certain holes. That is a P junction. You have, so at that point, there the hole, the electron is flowing from the N type to P type. So you have the electricity that is flowing in the entire circuit like this, right? So the electron flows, and you have the electricity being generated. So it is just a diode mechanism. You have the energy produced, electric current that is produced, which is a DC current in fact. So you can charge it using a controller, you can charge it inside a battery, and you can use it for a DC power, or else you can convert it, you can have an inverter and you can use it for a AC power. So basically you can use it anywhere where the sunlight is uh, available. So at a rooftop or any plain places, wherever you want, you can use it, and it's just a flat panel that you need it, which you would have seen at several places. So let's look at some examples. You have offshore oil drilling, refrigerator. These are domestic usages. You can use it for the signaling. You might have seen some signals where the solar panels are used, or even you can use it for the building. Here I have an example of Shri Sonam Wangchuk, who developed a solar heated tent for Indian armed forces in Ladakh. So in Ladakh, this winter season, the temperature goes to somewhere about minus 15, minus 20, minus 10 to minus 20 degree. It is ranging outside. So it is very difficult for the armed forces to survive over there. So he designed the tents for them where the outside temperature is somewhere about minus 10 or so, and inside the temperature is somewhere about 20 to 25, which is sufficient enough, like an AC room. So this is the same person on whom a novel was written by Chetan Bhagat, and later it was picturized in the form of Three Idiots movie. Same person. Then, Government of India has a lot of initiatives to promote solar energy. MNRE is the Ministry of New and Renewable Energy, which is dedicated for this purpose. So there are a lot of, you can go through the website, there are a lot of schemes on solar energy. Something like 40% subsidy under MNRE scheme is there. So up to 2 kilowatt, there are some limits available. So you have subsidy for the solar panel installation, for farmers, for pumping activities and irrigation purpose. They have Kusum Yojana, which means Kisan Urja Suraksha Uttan Maha Abhiyan. So there are several such schemes available by Ministry of New and Renewable Energy. You can go through this website and you get a lot of other projects also, not only solar, other projects also, renewable energy projects. Let's look into the another aspect or another type of renewable energy, that is bioenergy. So I have clubbed many things over here. Bioenergy you can have from biomass itself, which is the energy generated or produced by living or the once living, that is non-living, I mean they are dead now. So the most common biomass energy are the plants, corn or any log of wood also. So you are going to incinerate them, burn them. After burning you get the heat energy, which is used to produce steam, then to use it as a steam, use it for a steam turbine or use it as a steam for any other purpose. You have biodiesel, which is practically it is a methyl or ethyl ester produced from oil. So biodiesel is an alternative for the diesel fuel, which is produced from plant or animal lipids or the fat. Bioethanol is an alcoholic product which is produced by microbial fermentation from carbohydrates, sugar sources. So from sugar sources, bioethanol is produced. It is an alternative, or you can use it as a blend with the petrol or gasoline. Gasoline is also known as petrol. Biogas is also a product of biological process, that is a breakdown of organic matter under absence of oxygen, call it as anaerobic process. So they produce methane and some carbon dioxide. So this is done biologically. This biogas can be used as domestic purpose fuel or even industrial purpose fuel. You can produce it from agricultural waste or manure or municipal waste, solid waste you can use it, or in even food waste it can be generated. So let's look into the first one, that is a biomass briquette. So you can have briquettes that are formed from different sources. You can see here sawdust, bamboo, Swiss grass, then coffee husk. All these are converted into the form of briquette. How it is done? Say for example, you have a sawdust, you have a pelleting machine, you need to cool it because it gets heated up there. So you have to remove the moisture and cool it. Then you can pack it and supply it to the industry. Industry will use it for burning purpose for its furnaces. Another example we have is a biodiesel. So biodiesel is produced mainly from the seed and the oil is extracted out of it. In India we are mainly dependent upon the non-edible oil, which cannot be used for edible consumption. So this is for the US style. In US they use vegetable oil because it is surplus over there. In India we use non-edible oil, but the method remains the same. So you add alcohol to it, you convert that particular oil to ester, which is called as biodiesel. by a transesterification reaction with alcohol. So the transesterification reaction is used to convert oil to biodiesel. Meanwhile, you get glycerol as the byproduct, which can be used in different industries. So here, after you convert the seed to oil, you get the biomass, the remaining biomass, which can also be used for incineration purpose, which I mentioned earlier. So this biodiesel, what you produced, it can be used for production of energy in different vehicles, that is diesel engine vehicles. You can make use of this. So the carbon dioxide produced, again they can be consumed by the plant, and the same plant is used for producing seeds. So that is how the cycle is more sustainable. So the 10th August we celebrate World Biofuel Day or International Biofuel Day or Biodiesel Day. On this particular day in 1893 in Germany, Sir Rudolf Diesel, the scientist who invented diesel engine, he showed that the engine can run using the peanut oil. Remember, peanut oil is the precursor of the biodiesel. So for the first time in a diesel engine, it's not the diesel, it's the biodiesel that was used. So another type of fuel we have is bioethanol. You can have the sugarcane bioethanol, you can have corn ethanol, or you can have cellulosic ethanol. These are all the raw materials. You can have the sugarcane molasses, corn, you can directly use it, or cellulose, plant materials, you can use it. You need to pre-treat them. In all the cases, you end up with the sugar, that is the carbohydrate sources. They undergo the fermentation process. Then we recover the solids, that is the DDGS and lignin. These are all solids. We recover it. The liquid stream what we get, we distill it to produce bioethanol. Bioethanol is a renewable fuel. It's made from plant. It is high quality with a high octane number, and the GHG emissions are very low with this biofuel. Bioethanol can be blended with petrol. Biodiesel can be blended with diesel. Now we have another type of biofuel. This is a gaseous fuel, biogas. You can produce it from the livestock waste, or you can produce from crops or any wastewater, or even food waste. Domestic food waste you can make use of. Anaerobic digester is used where you create the biogas. The solids that you have can be used as a fertilizer, organic manure, or the biogas what you have can use it for the heat production, that is domestic heating, or even electricity. Now this biogas has got large amount of methane, that is more than 80%, and around some percentage of carbon dioxide. Now this is one sample of biogas unit. It is the not deep into the earth, it is a portable type on the surface of earth, right? Earlier old ones, if you see, it is the deep down the earth. Now the new models have come. This is a domestic one, a small unit you can have, somewhere about 100 liter, 200 liter, or 500 liter you can have it domestic. For a small house purpose you can make use of. It's a rooftop design, so you can keep it on the terrace also. In Nitte, we have a Bioenergy Research Information and Demonstration Center. You would have visited this place earlier. So in this center, we have the the seeds are processed. Then it is processed to produce the oil. You get the oil cake here. The oil is converted to biodiesel. This biodiesel, what you get, we sell it to the market, and we also use it in our college buses. Another type of renewable energy is wind energy. Wind energy, it's a form of energy that converts turbine, that the wind energy converted to kinetic energy by turbines. So you have a mechanical energy to electrical energy conversion. Now wind turbines, they are able to deliver electricity at a lower cost than the smaller turbines because of the foundation cost, planning of the cost, and the sizes are independent of each other. Now it is normally highly used for the offshore wind plants. In various where you have one large turbine, you can have a tall tower, you can have multiple setups, that's possible. We have different designs in this, right? So India has the fifth largest installed wind power capacity. In terms of total power, we are the top fifth. Now with that, we have 16,000 megawatt installed capacity, and mainly in Tamil Nadu we have in Gujarat. Tamil Nadu and Gujarat, those are offshore, the two sides of ocean, right? So we produce around 1.6% of country's requirement, total power requirement in fact it is. So it works like this. You have the turbine, you have the blades that are turning, we have at a pitch right? We have this hub is nothing but on which the blades are placed. It's just like our fan. On the top we have the fan. It is moving 90 degree to it, right? So the air moves this particular blade, and because of which you have the gearbox system which converts the entire power, the turbine, right? So turbine at the bottom, you have the conversion into the transformation process and convert it to the electrical line, electrical grid. This particular component on the top is called as nacelle, NACELLE, nacelle. So that's the top portion over here, which is converting the entire process, that is mechanical energy to the electrical energy system. So it has got a lot of advantages like that. They are renewable, no emissions, economically viable, and you can harness the energy so that you make it economical. But you have a problem with the noise and it can kill birds. That's true. So you have different designs here. You can put it on a plain top of a hill, or it can be in ocean, or and across the bridges, or you can have a rooftop. Another type of energy, renewable energy, is geothermal energy. As the name says, geothermal energy means thermal energy that is available, stored in the earth crust. So you pass the liquid to the earth crust, and it gets heated up, right? So that energy, that fluid, or the fluid that you create, that heat energy that you create, you use it for turning the turbine and generating the electricity. So it is estimated potential of around 10,000 megawatt is present in India, but not yet used that much. So we have an estimated potential. Potential means we need not use it; it's available for use. So right now we have around 7 geothermal provinces in India, not fully commissioned. In fact, we have in Himalayas, Sohana, West Coast, Cambay, and Narmada Basin, then Godavari Basin, Mahanadi Basin. Those are river basins. We have geothermal energy reservoirs. They have been identified. Another type of renewable energy you can think of is hydro energy. Hydroelectric energy, also called as hydroelectric power station, right? The reservoir dams, what we have the hydroelectric power stations associated with that. It's a form of energy that harnesses the power of water in the motion. The kinetic energy of water is converted to electrical energy here. So what happens here? The water flows in and it turns the turbine. The turbine turns the turbine generator shaft. The shaft is generated, and you have a stator and rotor mechanism that will be turning, and it generates the electricity. How it generates the electricity? A hydraulic turbine converts the energy from the flowing water to a mechanical energy. So hydraulic energy converted to the mechanical energy in terms of turbine motion. That turbine, it is mechanical energy in the turbine is converted into the electrical energy in the generator by the mechanism of Faraday's law. So the operation of generator is based on the principles of Faraday's law. So magnet is present, the stator and rotor are the magnets that are placed there. So when they move, you have the Faraday's law. From the principles of Faraday's law, you can generate the electricity. This is in a large operation. So India is the fifth globally installed hydroelectric power capacity. So we have in top 5 position, which is around 46,000 megawatt as on date. So it is the 13% of total utility power generation capacity. That means how much energy we require, we are supplying around 13% from this. So the leading one, that is the Koina hydroelectric project in Satara, Maharashtra. It is India's largest hydroelectric power plant. Then hydroelectric power plant at Darjeeling and Shivanasamudram. They are the oldest known in India as well as Asia. Then we have 197 hydropower plants in India as of now. So another one, you can say the power of tomorrow, the future fuel is hydrogen fuel. This a fuel cell is an electrochemical cell which is converting hydrogen gas into energy by a reaction with the oxygen. Oxygen react to produce water. So in this electrolysis process, electrochemical process, in fact, heat is generated, and that heat is used for propelling a vehicle. So this is mainly thought of as a ideological process. Hydrogen is filling into the tank, and that you have the series of hydrogen fuel cells that generate the energy and propel the car or any vehicle. So basically it works like this. You have the hydrogen gas flowing into the chamber, and through the semi-permeable membranes, that is the electrolytic process, from the anode to the cathode. When this gas is transported over here, at one end, that is at the cathode end, a reaction takes place, and as a result of that there will be a transmission of electrons and that generate the electric power. So that electric power you can make use to propel the car. So you can see that result is water and heat, only that much. So it is environmental friendly. In fact, you have a lot of water vapor being produced there. It is used to power personal electric devices. Even cell phone, iPads and laptops can be charged using this energy. It produces energy that sufficient enough to run for days and weeks, not even hours. It's more than that. So you can even run car, aeroplane and ship, it is thought of. So you can reduce greenhouse gas emission, that's around 60 million tons of carbon dioxide, because there is no carbon dioxide production over here. Now it is a development and a reliable catalyst required over here. That's the one problem over here, is that you need the process so that, or the component, so that you reduce the cost of it. That's one of the technology that needs to be improvised over here. So there are different applications, you can say. Even the space station or a military technology also can make use of hydrogen gas. Let's move on to a topic, that is energy conservation. We have thought of seen all the non-renewable and renewable energy sources. We know whether it is available or not, it gets exhausted, everything we say, right? We have ancient wisdom in Sanskrit. Mata Bhumi Putroham Pratviya. It means the earth is our mother, we are her children. Mahatma Gandhi has quoted, earth provides enough to satisfy every man's needs, but not every man's greed. So we should not be greed. We need to understand our need and utilize the resources carefully. So we need to understand fossil fuels are precious. We need to make judicious use of it. For the good of climate, for the good of health, of our own health and the future humankind, we need to make judicious use of these available resources. Note that more than 60% non-renewable have been consumed so far. We have only 40% available for our use. We need to promote renewable fuel production and its usage. Most important thing is this one. We may say that government comes with a policy, government will look into it. No. Small efforts by many will make a real impact, rather than by a big efforts by a few. Government make a big effort, but only few small steps it can take. But on a larger scale, if it has to happen, it's we the people living in the country needs to make that small effort from our side. What are all those small efforts? Yes, here we have. For example, these are just small list I have given you. There are many things that you can think of. You can turn off unnecessary lights and fans. You can use natural light. You can use LEDs for lighting. You can replace fluorescent lamps. So you can have shorter showers. You can save water here, right? Turn off water when shaving, washing hands, brushing the teeth, or even taking bath. Fix that leaky faucet. Faucets may be leaking. Ensure that it is properly fixed. You can unplug unused electronics. If you have electronics running, simply switch it on. You can switch it off. You are not at home, you can turn off the air conditioner. You can use the optimal condition in the air conditioner, that is 24 to 26 degrees Celsius. That's sufficient for the human. We do not require 19 degree or 20 degree, which consumes more energy. Then you can recycle the electronics. Simply don't dump it. Recycle. Give it to the recycling units. So you can reuse the resources. So you can make a routine maintenance of your electronic. So maintenance makes more efficient, keeps it efficient. If you do not maintain it, it is not efficient enough. You can make use of public transport or pool transport. So that way you can save the fuel. You can use renewable sources wherever applicable. You can promote the usage of renewable resources. So the most importantly, why you are learning this particular course, that is environmental studies, is for this particular reason. The engineering graduate, it's not that you may be in any field. It is not important which field you are. In any field you can make your contribution. Could be anything related over here. You can make some project. You can be involved in a project where you can think of this particular concept of sustainable future, sustainable, that is environmental concern. If you bring that particular concept in your project or your work, whatever you may be working in, that's a great impact you are making. So under the program outcomes of any engineering degree, you have a program outcome on this particular concept. that you need to be uh, you need to be having a sustainable developed project. You need to have environmental concern. You need to understand the requirements of a given project, which is viable, which is sustainable and environmental friendly. By that, I close my this lecture and even this unit. Thank you.